For this video, we're going to use transformations to sketch, make a sketch of the graphs of logarithmic functions. So I'm not going to use a calculator, a graphic calculator at all. So for these two functions. So let's start out with this one. Okay, and the thing to recognize about this is if I'm going to use transformation, I'm going to start with the basic logarithmic function, taking it at base 2, and just having x there. So I'm going to start with that because we do have two basic ways we can look at this. The base is 2, so my base is a number bigger than 1. So my basic function is going to look like this. Okay, so I'll get back to where I am here. And so for that, I've got, if the base is 2, then it's going to look something like this. So a is equal to 2, so I'll always have the point 1, 0, but I'll also have this point on here. And with this kind of thing, there's no horizontal asymptote. There is a vertical asymptote, it's the y-axis. So the vertical asymptote, the y-axis written as a line, is the equation x equals 0. There's no y-intercept. I do have an x-intercept, it's 1, 0. And as I move from left to right, I'm always going uphill, so this is an increasing function. And what else can we say about this? What about the domain and range? Well, the domain, I use the x-axis to measure how wide, and so I'm going to start at but not include 0, and then it'll go on forever. And what about the range? Well, I'm going to use the y-axis to measure how tall from bottom to top. There is no bottom, and there is no top. Okay, so that's my basic function. Now I want to get this function from my basic function. So the next thing I'm going to do is I'm going to replace x with x plus 50. Now when you replace x with x plus a number in the graph of the function, so I'm going to replace x with x plus the number, it's going to shift it that many units to the left. Okay, so I'm going to take this one and shift it 50 units to the left. So where my vertical asymptote was the y-axis, my new vertical asymptote is going to be 50 units to the left. So that's my new vertical asymptote, x equals minus 50. And this point, 1, 0, if I shift it 50 units to the left, then I'm going to have negative 49, 0. And so this is going to look kind of like that. Okay, so just sketching. And so my x-intercept is going to be negative 49, 0. There will be no horizontal asymptote. As I go from left to right, it is going uphill, so it's still increasing. Okay. Now what about domain and range? Well, if I use the x-axis to measure how wide, I'm going to start at but not include negative 50. And then it keeps going forever. And for range, if I use y-axis to measure how tall from bottom to top, I'm still at negative infinity to positive infinity. And then the only thing I need to do here is, what is the y-intercept? This one definitely has one. And to find a y-intercept, you plug in x equals 0. So if I plug in 0, 0 plus 50 is going to give me that. Okay, now that's an irrational number, so my y-intercept is at 0, the logarithm of 50 taken at base 2. Now, if you were told to get that to 3 decimal places, okay, Okay, well, I can do that if I get my calculator up there. And so, what is log of 50 taken at base 2? Well, my calculator doesn't do base 2, so I'm going to have to do a conversion. So I'll do base 10, which will be just log of 50 divided by log of 2. Okay, so if I take that to 3 decimal places, that's 5.644. Okay. And then finally, I'm going to get the graph that I want. I'm going to take this one, the formula, and I'm going to add 300. When you add something to the end of a formula, it just shifts it up. So I'm going to have this, and then plus 300, and that gives me my formula for G. So what does the graph of this look like? It looks like this, shifted up 300 units. So my vertical asymptote is still the same. It's x equals negative 50. Okay, but if I shift this 300 units up, okay, then my going left to right, I'm still increasing. My domain is still negative 50 to infinity. My range is still negative infinity to positive infinity. Okay, what is my y-intercept? Well, my y-intercept is going to be the y-intercept here, but shifted 300 units up. So it's going to be 0, comma, if I want the exact answer, it's going to be that. If I want an approximation, it's going to be 300 plus the approximation there, so that. All right, there's no horizontal asymptote. And the only other thing I have to get is, where is this x-intercept? Okay, well, to get for the x-intercept, you put y equals to 0, or in this case, g of x equals 0. And that means I have to solve that. So I could subtract 300 from both sides. And then why don't I change from logarithmic form to exponential form? So I'll have 2 to the negative 300 is equal to x plus 50. And then if I subtract 50 from that, I'll get my x coordinate. So the x coordinate here is very, 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 very close to negative 50. 2 to the negative 300, that's going to be a decimal with lots and lots of zeros. That's the same as 1 over 2 to the 300th. Okay, but if you try and approximate that to, say, 3 decimal places, you're going to get negative 50, which is an error. So I'm just giving the exact answer, which is negative 50 plus a tiny, tiny bit. Okay. So that's what we have for that one. Now, what about this other one? I'll do it quickly. I'm going to start with the basic function, the logarithm of x taken at the base 1/2. Okay, and if I have that, so that's what I'm going to start with. And you can see that the base is 1/2, so we're in this situation over here. Okay, so the graph of that is going to look like this. The vertical asymptote is the y-axis. There's no horizontal asymptote. There's no y-intercept. The x-intercept is 1, 0. As I move from left to right, I'm going downhill, so it's a decreasing function. My domain goes from 0, but starting at but not including 0, to infinity. And my range, bottom to top, well, negative infinity to positive infinity. Okay. So now how do I get this from this? All right, the next thing I might do is just negate the front there. Now what happens when you negate out the front? Well, I'm going to reflect it in the x-axis. So I'm going to take this and reflect it in the x-axis. So that's not going to go anywhere. And this is what I get for the graph of that. So my vertical asymptote is still the y-axis. There's no horizontal asymptote. There's no y-intercept. The x-intercept is 1, 0. As I move from left to right, I'm going uphill, so it's an increasing function. My domain, using x-axis to measure how wide I start at, but I don't include 0, and then on to infinity. And my range, use y-axis to measure bottom to top. There is no bottom, there is no top. Okay. And then finally, how do I turn this into that? Well, I replace the x with x plus 10. And so it's going to take the graph of this and shift it 10 units left. So if I shift 10 units left, I'm going to get, well, my vertical asymptote is the y-axis. So my new vertical asymptote here is going to be the vertical line x equals negative 10. And this x-intercept is going to be shifted 10 units left. So my x-intercept is going to be negative 9, 0. And as I move from left to right, I'm going uphill, so it's increasing. There's no horizontal asymptote. My domain, use x-axis to measure how wide. I'm going to start at but not include negative 10, and then this is going to go on forever. And my range, I use y-axis to measure bottom to top. There's no bottom, there's no top. It's going from negative infinity to positive infinity. The only thing I have left to get here is this y-intercept. Okay, now we find the y-intercept. Well, the x-coordinate is 0. So what I do is I plug, and then of course this is my function h of x that I wanted. And so I just plug x equals 0 into this equation. And so I get that. Now, if you were going to write that, so that's an exact answer. If I was going to approximate it to 3 decimal places, and I want to put that in my calculator can only do calculations in base 10 and base E. I'll take it to base 10. The log of 10, the common logarithm of 10 is just 1. And let's see what that number is if I had to approximate it. So if I want the negative of 1 over the common logarithm of a half, which I'm just going to put in here is 0.5. And that is approximately, if I take it to 3 places, 3.322. Okay. And so that is where this would be. And that ends this video.